Hello and welcome everyone to my global Azure session. It's really great to have you here, and I'm happy to share with you today 4 different options how we can work with Kafka on Azure. Now, I want to do that primarily from my own developer's perspective and my own experiences on that topic. So you shouldn't expect that to be a deep dive kind of exploration from an operational perspective only. Instead, see that more of a first navigational aid that should help you to figure out what could be your own best approach to work with Kafka on Azure. A little housekeeping up front. So there is a YouTube live chat, which you can use to post your questions into. I think it makes sense to postpone them until the end of the talk. I think it's easier to handle it that way. I have reserved a couple of minutes at the end, and should we run out of time, there is also this Discord channel available, which we can use for a post-talk discussion. So I really hope to see many of you there to share anything about Kafka or Kafka in combination with Azure afterwards. So before we dive in, let's take one step back and ask ourselves, why should we even talk about that event streaming platform called Kafka, and why do we want to use it together with Azure? So I think every one of us is managing and processing data in various different ways, various different kinds of data, various different volumes of data. And we typically don't do that for the sake of its own. Instead, we try to gain hidden insights from that data. And we do that in turn to drive value. So at the end of the day, it's about making money with what we do. And while this process to go from data to insights to value sounds pretty straightforward, in fact, it's not like as trivial as it sounds. So there is, to some degree, time which is working against us. We have this inherent challenge that we have to cope with, which is called the diminishing value of data. The idea behind it is to investigate the relationship between the age of our data, which we see here on that slide, on the bottom, on the horizontal axis, at different granularities. So from sub-second all the way up to days and months old data. Now, when we contrast that data with the value it can bring for decision-making, which we see on the y-axis here, and when we would inspect that relationship closer, we would see that the distribution is actually one in which the value of our data rapidly drops as the age increases. So in other words, this means the older the data, the less value it typically brings for our business decisions. Now, unfortunately, most of today's data processing is still happening too far at the right side of this distribution here. This means we are mostly operating on historical data, which exhibits relatively little value. Now, when we use specific technologies that were designed for data in motion scenarios, we can achieve a shift towards the left side of that distribution and thereby try to maximize the value. And we can then also support business critical decisions in a much, much better way. And in fact, this shift from traditional kind of batch-driven thinking and batch-driven tooling towards the left of near real-time processing to come up with answers faster is what kept and still keeps me quite busy these days. So when talking about me, my name is Hans-Peter. I'm currently based in Graz. I'm working here as a technical trainer for Java development, mostly at Netconomy. I'm doing that part-time, and this means I have some time for also working in my role as an independent consultant and engineer, where I work with clients to build what I tend to call modern data architectures. So what I mean by that is most of the time it involves event-driven application designs built on top of Kafka or similar other tools regarding messaging, and then combining that with non-relational data stores such as MongoDB. Time permitting, I try to be an active community member in both communities. So my work that I did and am still doing these days in the community is mostly related to this intersection of the Apache Kafka and MongoDB communities. So I did some code contributions, blog post writing, and I do some conference talks on these topics. But enough about me. Let's start this journey and first try to just get a brief understanding so that everyone is roughly on the same page here about what it means when we say Kafka is an event streaming platform. So the term stream processing can be looked at from various different angles, of course. And there are also definitions out there. I'm not a big fan of definitions, honestly, but there is one explanation which is pretty simple, generic, but it still captures the essence of what stream processing, or streaming for short, is all about. And it's described by a guy called Tyler Akidau as data processing, which is designed with infinite data sets in mind. And the essence here is the infinite data sets part. And we need, in order to support such never-ending streams of data and computation on top of those streams, we need purpose-built technology to do that. And Apache Kafka as an event streaming platform allows us to do exactly that. So talking about Apache Kafka, most people still today think that it is just yet another message broker. And while it's true that it all started out years ago as a messaging system for basic pub/sub scenarios, we do many more things today with Apache Kafka. We use it to run complex high ingest data integration pipelines. We use it for near real-time processing of data, stateful processing, stateless processing. And another great aspect of Kafka is that the data we write to it is not an ephemeral thing. This means when we have processed data, it's not gone. So Kafka gives us, if we want to have that, more or less permanent storage. We can very precisely decide how long we want to keep our data around. We could even keep it around indefinitely if we have enough storage to do that. Now, Kafka is there to work from various different applications that we build on top of Kafka. And I want to briefly walk you through the main touch points here that you would interact with when you develop solutions on top of Kafka. So first, on a very low level, we have this producer-consumer API. We use producers to send basically arbitrary data into Kafka. Kafka doesn't care. All it does is it stores sequences of bytes. So the message structure that we have on the application layer is dealt at the serialization level here. We can then consume that data from so-called Kafka topics, which store this data partitioned for fault tolerance and scalability reasons. So typically, all your data is there and replicated 3 times in a 3-node cluster. And when we consume that data, we have a lot of freedom to do that. We can decide where in a topic we want to start reading. Also, multiple different applications can consume one and the same data. So it's not that if one message is processed, it's done and it's gone. It stays there. We could even go back in time with one and the same application and replay data from the past if we would use that. Now, these low-level APIs are more or less there for all popular programming languages. This means you can use it from the language of your choice, whatever is your personal taste here. Then we can shift away from the application layer towards more the storage and persistence connectivity between systems. So we can use Kafka as this decoupling element and integrate any 2 systems across our landscape with one another. We do that by means of Kafka Connect. It's an API, it's a framework, it's a runtime, and there are many turnkey-ready connectors out there, for instance, which allow us to bring data changes that are happening in a relational database system into Kafka topics. And from there, we can address more or less any supported target system, again, using available sync connectors for that. Ideally, you do not have to write any code because those integration code that is needed for specific data stores is already written by someone else. Then we have the stream processing part. And here we have to differentiate 2 different ways to do stream processing on top of Kafka. We can use the Streams API. We can integrate this library into our Java code, just write our data transformations there. Or we could, on the other hand, say we want to have more higher level abstractions, a SQL-based layer on top of this Kafka Streams API, which means you then don't have to bring Java or other programming skills to the table. All you would do is you would specify your stream processing application as a sequence of multiple SQL statements, hand it to a node that processes this SQL statements, under the covers generates those Kafka Streams applications and runs the job. Now, why, you might wonder, why do you need this stream processing application if I have this producer consumer API anyway? And this is a good question. And I think the stream processing API is a very good choice whenever you have this typical read, process, write loop in your applications. Meaning you read some data, you do some stateful or stateless processing on it, and you write the results back, you feed it back into other Kafka topics. This is a perfect fit where you would use Streams API. Now, these major touch points for writing Kafka applications, together with its core characteristics being a distributed system that is very scalable and also fault tolerant, enables Kafka to be put at the heart of data architectures. It can act as this central nervous system, which allows you to literally handle all data flows of any kind that would happen across your companies. Now, I hope you have a rough understanding, at least based on that kind of bare minimum introduction into Kafka, what it allows you to do. And with that, I want to shift focus over now to understand those different options that we have in order to work with Kafka on Azure. And I want to start doing that with Azure HDInsight for Kafka. Now, when we talk about HDInsight, it makes sense to go back a few years in time, because HDInsight originally started as something else. So Microsoft started to offer several years ago in the context of big data processing. And yes, I'm using that term here because this was the term that was used back then, heavily everywhere basically. And it started to offer something that they called Hadoop on Azure. And so basically it all started with a Hadoop kind of offering. And later on, Microsoft decided to gradually evolve that offering and add several different components of the so-called Hadoop ecosystem to it. So today, HDInsight is an umbrella term for a family of multiple different services that we would find. And these services allow for various different use cases. We can use HDInsight for this large-scale parallel processing where it all started. We can also use it to build data warehousing scenarios on top of that. Or we could use it to do stream processing with HDInsight too. You could even say you want to use HDInsight related services for distributed machine learning workloads. And all of that becomes possible because HDInsight allows us to provision various different cluster types. So what we see on that slide here is the various different technologies that HDInsight offers as a service on Azure. So we have, again, a Hadoop where it all started with this MapReduce kind of workloads and the distributed file system called HDFS. We have Storm for low latency record by record stream processing. We have Spark, which we can use for various different things. We can build a SQL based data warehouse abstraction on top of Hadoop based on Hive. And we could use HDInsight and HBase as a NoSQL offering on top of, again, Hadoop. And all of this is basically under the Apache Software Foundation and open source software. And at one point, Microsoft decided to add HDInsight for Kafka here. So this is what we want to talk about a little bit more. So what do we get when we would deploy HDInsight for Kafka? First of all, it's a managed service by Microsoft. We have it backed with SLAs. We have uptime guarantees of 3 nines. What basically gets provisioned for us here is a set of multiple VMs on Azure, and these VMs then host the different processes that a Kafka cluster needs. Now, that is the Kafka brokers themselves paired with Zookeeper nodes. If you're wondering what that is, so Zookeeper is another Apache project, and very simply speaking, it's still used by Kafka today for everything related to reliably running a distributed system. So Kafka uses it for things like quorum protocol, leader election, cluster configuration management, that kind of thing. And I think it's good to know here that Zookeeper is something that will eventually be gone. So there is a lot of work underway, and there are already first versions, POC versions, of a Zookeeper-less Kafka, as we tend to call it. So Zookeeper as an additional component to run next to Kafka brokers will be gone in the near future. But today it's still there. And what we get is we get a deployment that typically starts with 3 nodes for each. So we get at least 6 worker node VMs for HDInsight. And we get, in addition to that, managed storage, managed disks that can grow in size up to 16 terabytes per broker. When it comes to provisioning that, we have many different options. We can use, of course, the convenience of the Azure portal, do a few clicks, and have our cluster provisioned. We could use our favorite SDKs. We would probably do that as developers, more likely than just clicking around. We could use PowerShell scripts. We could say, no, we want to directly work with ARM templates that we send against Azure Resource Manager. Or we could even choose infrastructure as a service abstractions, such as Terraform. I think there is a Terraform session right after this one. So if you're interested how to work with infrastructure as code in Azure, you might want to join that. So all those options are there that we can use to provision HDInsight for Kafka on Azure. Now, once that cluster is provisioned, we, of course, want to work with it. We don't provision this cluster to sit there idle and just burn money. We want to write applications against it. And here it's a bit special because what we get from HDInsight per default, so if we don't take any further actions, is a system that we cannot easily access from the outside world. And this is a bit, again, special when provisioning cloud systems because you assume you can use them from your client applications. And here we would need to more or less configure and open up access to the broker nodes that are run inside this offering manually, more or less. And we have different ways for that. We could say our client applications should run on the same VNet. So this whole HDInsight thing runs in its isolated VNet per default. And you could say I spin up another VM there and run my client application there. Then it talks to Kafka in the same VNet. You could say, no, I want to isolate that. I want to provision a separate VNet and then run my applications over there. This allows you to then, again, use concepts like VNet peering to bring those two separate VNets together. Another option would be to say, well, my clients, maybe they should run on premises somewhere. Then also that's an option to connect your private network with the VNet in Azure using VPN gateway for that. And finally, another option here would be if you say, all I want is HTTP-based access for clients that only talk HTTP, I could provision a Kafka REST proxy that basically sits in front of Kafka as a proxy, right? A facade layer, if you want, offering this REST API to the outside world, to the external clients, and internally then talks to the Kafka brokers behind the scenes. This is not all the options that you have. There are others as well, but this should give you an idea how you could then work with such a provision cluster based on the HDInsight service for Kafka. Now, in summary, what do we get from Azure HDInsight for Kafka? So we get really easy provisioning options for it. We also get pretty flexible pricing. If I have that correctly in mind, they charge these nodes even on a per minute basis. So that means you can really make use of this in a pay-per-use sense quite nicely. Also, it's an offering, again, worth highlighting, that is just using open source components under the covers. So this means there are no components regarding Kafka that would come with a separate special kind of commercial license. No other third parties are involved in that offering. You use basically open source Kafka backed by Microsoft with corresponding SLAs. Of course, there are some drawbacks to that offering, and I think first and foremost, it's important to mention here that we have to stick to a rather outdated version of Kafka. So even HDInsight 4.0 is based on Kafka 2.1.1, and this basically means this is a Kafka version that is about 2 years old. We have Kafka 2.7 today. And I think this is not really related to Kafka on HDInsight. When you would take a closer look at some of the other offerings under the HDInsight umbrella, Microsoft has always been a little bit hesitant to upgrade those versions to the newest ones. So also for Spark, Storm, or other HDInsight things, they are slightly lagging behind in version recency. Again, you get only core Kafka. What I mean by that is the brokers and Zookeeper, but nothing else. But if you have heard about some of the components around Kafka, I mentioned one earlier, for instance, Kafka Connect, something that you would run next to your brokers. In this scenario, you would need to run that on your own. So there is no option to have that included here. And we talked about that briefly. You have to make sure to find your proper configuration, how you want to work with those provision brokers from your client applications and configure these external access options accordingly. With that, I want to switch over to the second option that we have, and this is Azure EventHubs for Kafka. Now, first, Azure EventHubs in a nutshell, what it is a fully managed PaaS, and Microsoft describes it as this distributed event ingestion service. And the really great thing about Azure EventHubs is that it is extremely well integrated into more or less the other Azure portfolio that matters for this offering. So you can really nicely integrate with complementary services here, meaning things like Azure IoT Hub or Azure Event Grid. You could integrate with Azure Functions and other components there. So this works really, really well in combination together. Also, you get auto-scaling capabilities. They call it auto-inflate. It's a functionality that allows you to just provision throughput, basically messages per second that you want to ingest here, or throughput in terms of volume. And you have these throughput units as this abstract scaling unit there, and you could then configure boundaries between these boundaries. Then you have this auto-inflate and auto-scaling options. So when we talk about Azure EventHubs, the big picture to understand this offering is that Azure EventHubs, you first of all have an EventHubs namespace. And this EventHubs namespace contains many different event hubs. Now, the event hub is this thing which you really interact with and write your data to. And this event hub is also partitioned in the sense that it allows us then to have parallel consumption for consumers. So to get data into Azure Event Hubs, originally you had two choices. You could use the AMQP protocol, or you could do that as well based on HTTP clients. And later on, this was extended there, and I'll come to that point. When we go to the consumption side here, we would see that, again, there is this concept of consuming applications that can form groups. And a consumer group is nothing else than a logical combination of multiple application instances that should share the load of processing data from one and the same event hub, which spans multiple partitions. In other words, this means the more partitions you have in your event hub, the more scalability you get from a consumption side of view. So you can, for instance, provision 16 partitions in your event hub. And then this particular event hub, you could use up to 16 instances of your application in one consumer group, and they would then consume each from one of those partitions. So when we compare that design of Azure EventHubs with, on a very high level, so conceptually with Kafka, we would realize they are more or less lookalikes. Conceptually, design-wise, is what I mean here. So both are partitioned log implementations, and both give the client a lot of control in how and what data they want to consume in what ways. I think it was just a matter of time and almost a logical consequence until Microsoft decided to extend that offering, in the sense that they built an overlay, a protocol-compatible overlay over EventHubs, which is supporting Kafka 1.0 or newer clients. And the idea behind that is that you can reuse existing applications, which were originally written against Kafka, and also reuse familiar tooling, and then switch it over to Azure EventHubs for Kafka instead. Now, this protocol compatibility layer even brings that offering closer to Kafka, to Apache Kafka in that sense. So almost striking similarity here. Same, but still different are these two offerings in the sense that whenever we have this protocol compatibility layer, I guess we all know that this can only ever be a best effort thing. In other words, this means when you build a protocol compatibility for something that you do not control, it's more or less chasing an ever-moving target. And because of that, this virtual promise there is to use Azure EventHubs for Kafka as a drop-in replacement only holds to some degree. So the idea here is, again, you have your application written against Kafka or your tool that you use with Kafka, and you would just point it by means of a different connection string to Azure EventHubs for Kafka, and ideally everything is working fine. And yes, for a lot of basic scenarios, this is true. This works very, very well. But again, here the devil is in the details, and you should be aware of the fact that when you use it for more complex Kafka-based scenarios, you might reach the point where you will face some limitations and restrictions. And there is several notable Kafka or Kafka protocol features that we don't have today for Azure EventHubs for Kafka. And I think it's not necessary to go through all of these one by one here. I put it more or less there as a reference, but what you should take away here is that when you use Azure EventHubs for Kafka, and you would absolutely need for your use case one of those features that are listed here, at the moment, this would basically rule out to switch over to EventHubs for Kafka because these are things that are currently not supported. For some of them, you might find workarounds. For some others, they simply don't work. And it's unsure from a roadmap perspective if some of the features will ever be integrated in the foreseeable future. So that's to some degree hard to know as of today. Now, in that regard, there is also some customer feedback. And here, I think it was called user voices back in the days. And here, again, just a few ones where customers express their wish for certain quotas and limitations to be removed for that offering so that Microsoft opens up a few more scenarios in an easier way. Again, you may find workarounds for some of them, but it's not as straightforward to just use it as is without the need to think about it further. So what do we get from EventHubs for Kafka? I think the great thing for this solution is that we can use it for hybrid messaging scenarios. And what I mean by that is this option that we can talk to one endpoint from various different angles and protocols. So we can use it with AMQP clients. We can use it for HTTP clients. And yes, we can use it even for basic PubSub and Kafka clients. So that works very, very well. Also, this elastic scaling feature called auto-inflate is quite interesting for if your use case needs that. And finally, we can summarize that we get an Azure native experience with a Kafka-like behavior. This is what it boils down to. And Whether or not this fits your use case is, of course, depending on all those details regarding which feature set do you really need from Kafka. Can you live with some of the restrictions? Yes or no. So yeah, the drawbacks, I think we addressed them. No need to reiterate that here. Just be aware of the fact that while certain things work pretty smooth, others will bring you into some further considerations how to deal with them. With that, I want to switch to the third option, which is Confluent Cloud on Azure. And no worries, this is not a new, different kind of cloud computing offering. So it's not another hyperscaler. It's an offering built from the original creators of Kafka. And the company behind that is called Confluent. And their fully managed Kafka as a service offering is called Confluent Cloud. And I think it's safe to say at that point that this service offering is, as of today, really the most complete and versatile offering to run Kafka in the cloud. What we get from it is a cloud-native Kafka as a service offering, which also supports elastic scalability. So when I say cloud-native, I basically mean that they run it and operate it behind the scenes also on top of Kubernetes and a bunch of other things. But this is what it boils down to from a technology perspective. So it's Kafka that is run on Kubernetes and adds a lot of things that aren't easily available with other offerings on the market at the moment. Also, Confluent Cloud supports those different scenarios where you would want, for instance, to use a hybrid cloud strategy. So you can use Confluent Cloud on Azure together with your on-premise cluster of Kafka that you might run and combine these two into a hybrid solution. Also, it supports multi-cloud. So this means Confluent Cloud is not only available on Azure, but also on other cloud providers out there. Worth mentioning again, I think, is that you get Kafka as a managed service by the original creators. So it's also safe to assume that it's probably harder to find a competitor that does a much better job and brings more experience to the table for running your Kafka clusters in production than Confluent with their service offering. So they are really, really competitive in that regard. When I said it's the most complete offering, what I meant here is that this allows us to reach beyond core Kafka, meaning they not only operate Kafka for us, they operate additional components also in a managed way, things like a Kafka Connect cluster that we use for these data integration scenarios behind the scenes. They manage those nodes. They manage also the connectors themselves that we run on top of those nodes to build these configuration-based data integration scenarios. Of course, this means they will provision more resources and it will consume more infrastructure under the covers. This means everything that you need in addition, of course, increases your cost there. So don't see that as something that you would get to the same for the same cost than running Kafka itself. This comes in addition to that and takes computing resources, of course. Another thing that they give us in a fully managed way is a component called the schema registry. So the schema registry is there to make sure that the data we write into Kafka follows certain rules. Basically, that we can validate the compatibility of the payload with the data that is already there at the moment. And this helps us, of course, to prevent writing data to a topic exhibiting a wrong or incompatible structure, which would maybe break downstream consumers. So this is a really vital component for many enterprise scenarios to make sure that you don't end up with, ill-structured data, let's put it like that, in your topics. Also, remember I said for stream processing, we can use this SQL abstraction layer, and this KSQL DB product is a separate offering from Confluent, comes also with an own license in that regard. And this offering is in that sense not coming with an OSI compliant open source license. So this is a commercial offering that they run for us in that regard. But we can use it to do SQL-based stream processing with relative ease. We can also use it to do interactive key lookups. What I mean by that is we could do point-in-time queries against a stream processing application and retrieve values in a poll-based fashion at query time. So another currently unique offering to Confluent Cloud is really interesting. It's called tiered storage, and this is something that is not available at the moment from any other product. It's basically means we can detach the complete storage layer for the data from the brokers themselves, meaning we can have the brokers provisioned. They host, let's call it the hot set of our data, so the fresher, the more recent data. And for data that is older, instead of cleaning it out based on retention policies, we could move that into cheaper cloud storage for archival purposes. But the good part is that this process happens, first of all, automatically, and the data is not locked away. So we could still access that data as if it would be fresh data. Of course, it has then higher latencies to do that data access, but all of that happens transparently under the covers. So this means virtually unlimited data growth or infinite retention time for the data that we store into our Kafka cluster topics. The only downside from an Azure perspective here is, at the moment, unfortunately, you cannot do that based on Azure Blob Storage. I'm sure this will come, but it's not fully there yet. So I think it's just a matter of time until we see blob storage support from Azure for this tiered storage functionality. Also, this tiered storage functionality at one point should come to Kafka, to the open source distribution of Kafka as well. But it's also, it will take more time, and it needs some contributions from one of these huge companies that are also working behind the scenes on tiered storage. One of them is Uber. So when we want to provision Confluent Cloud on Azure, how can we do that? So we could say we use Azure, so we use the Azure Marketplace integration on the one hand, or we could do that directly at Confluent side. I think talking about marketplace integration is important, because this is definitely a very cool option when you are already invested in Azure anyway, because it basically means this Confluent Cloud cluster that will run on Azure can be nicely bound to one of your subscriptions. Also, you can benefit from Azure billing integration. So no need to mess around with additional payment methods, separate invoicing, or anything like that. Also, no need to create a separate account at Confluent side at all. You can use Azure Active Directory and single sign-on to directly jump from your Azure portal over to the management UI that you would find on Confluent side here to manage and inspect your Confluent Cloud Apache Kafka cluster. So what do we get from this offering? We get fully managed Kafka by the original creators. We can have it run on Azure. We have support for this hybrid or multi-cloud scenarios. And we have, at the moment, at least the most competitive solution, in the sense that a smooth and wide integration to use components that go beyond core open source core Kafka here. The downsides here, I would really encourage you to take a look at the pricing, because this offering is not particularly cheap. So it's definitely advisable to look into the costs, what that means and how that compares to other offerings. Also, if you would want to directly interact with the underlying infrastructure that's provisioned on Kubernetes and that layer, you simply can't, because we are not even meant to see that. So all of that is abstracted away here. So we cannot tweak and tune it at will if we decide for that option. And another aspect to consider is that we have, of course, this higher degree of a separate vendor to which we have a certain dependence here. So ultimately, let's come to the fourth and final option, which is Kafka on Kubernetes. And Kubernetes, in a nutshell, is just an open source container orchestration system. There were already two sessions about Kubernetes on Azure today. We use it to deploy, manage, and scale our containerized applications. And it's one of these CNCF umbrella projects that is quite famous, and I think the de facto standard to do cluster computation based on containers today. Now, talking about Kubernetes, you might wonder immediately why. Why should I want to do that? Why at all? I mean, this, when we think about it, it means we need to not only get Kafka deployment on top of Kubernetes, right? But we would need to run Kubernetes itself. And this is a completely different undertaking. It's challenging. So if you consider to use Kafka deployment on Kubernetes, my recommendation here clearly is, please, by all means, do that based on a fully managed Kubernetes offering. And in that regard, we have, of course, AKS on Azure, which is coming to the rescue here for us. So we don't have to mess around with Kubernetes itself. We can focus on getting Kafka deployments right. And this comes with its own challenges. And those remaining challenges here, they are referring to running Kafka properly on AKS, because this is also not easy. There are several things to consider. Networking, you need to, you have all those different ways to define networking, node boards, service ingress, load balancers. So all these Kubernetes concepts together with Kafka configurations, you need to get right as from a networking perspective. Then storage. So Kafka, of course, is distributed. It's a stateful service. It needs solid persistence. Otherwise, it doesn't work. Meaning, again, in the context of Kubernetes, we need to think about stateful sets. We need to deal with persistent volumes, volume claims, proper storage classes. And finally, security. Never something for the faint of heart. So you want not only your Kafka pods and Zookeeper pods to have a secure communication, ideally MTLS based. You also want client applications to use secure channels. Maybe you want to support those clients with secure connections that are running not on the same AKS cluster and things like that. And if you get anything of that wrong, it's almost a recipe for disaster. So here comes my second recommendation when you think about working with Kafka on AKS. Please, by all means, don't do it on your own. Use something called a Kubernetes operator to help you there. Delegate away the burden to get all those peculiarities correctly configured. And an operator, I think you can see an operator as some form of human operational knowledge that is encoded into software. So an operator at the end of the day is nothing else than a program that runs and knows how to provision certain systems. And on the Operator Hub, this is a public registry where you find many different operators for various kinds of deployments on Kubernetes. And you find also those that address Kafka deployments. And the great option in that regard is, for instance, Strimzi. It's a fully open source based offering, great community, comprehensive documentation, and it's commercially backed by Red Hat. So what Strimzi brings is actually a set of multiple operators that allow us to not only manage our cluster, but also manage topics, manage users. And we can use Strimzi to go beyond core Kafka again. We can use it for different deployment capabilities. We can run Kafka Connect and manage connectors with it. We can use Mirror Maker to replicate from one Kafka cluster into another Kafka cluster. We can also introduce this HTTP bridge, which allows then REST clients to talk with our Kafka cluster. And there is cruise control, which helps us to keeping our partition usage balanced across those nodes. So many great things that Strimzi takes care of for us. So what do we get with Kafka on AKS together with an operator such as Strimzi. We get Kubernetes native experience, and thanks to the Strimzi operator, we don't get just something up and running. We get a reasonably secured deployment too. Also, in contrast to the previous offering, we see everything that the operator does on our AKS deployment. We can see all the bots. We can inspect all the YAML if we want to. We can tweak and tune it to our own liking. So this makes it a great choice for non-ops savvy folks, and I would count myself as one of these people too. So it's really easy to use when we leverage an operator such as Strimzi. The downside here is Kafka is still our own responsibility. Don't forget that. Even if we run on managed Kubernetes with SLAs, Microsoft doesn't support what we run on top of Kubernetes, in that sense, Kafka. So also keep in mind that when you go that route, you should have a certain amount of Kubernetes knowledge, despite all the magic that this operator does for us behind the scenes, because at one point, things won't go according to plan, and then you are on your own. So you don't get support for that part from Microsoft. This brings me to the end, actually, of today's journey. And there's one thing I want you to take away from it. I hope you saw this talk as this navigational aid that it should be, so that you don't have to just roll the dice at the end of the day when you think about how you want to work with Kafka on Azure for your own needs. Please use that as a starting point to dig deeper, so that you are hopefully able to navigate further and have a smooth Kafka journey that best fits your own projects and needs. With that, I really thank you for taking the time and listening. If you're interested, the slides can be already found online under this bit.ly URL. I'm happy to use the last couple of minutes to take some questions from the chat. And again, please, if we can't answer your questions there, please join me over on Discord. So I will go now and take a look into StreamYard if we see any questions at the moment. I don't see a question there. So if you don't have any right now, that's perfectly fine. Again, the reminder, I think after closing this session, I will immediately head over to the Discord channel. There's a dedicated channel called Kafka. Hope to see many of you there. Again, thanks a lot for having me. It was a great pleasure to be here. Enjoy the rest of Global Azure 2021.